Okay, so this is video number 2. On these last 4, all we're trying to find out is if it has one solution, infinitely many solutions, or no solution. Or mostly what we're going to be dealing with here is infinitely many or no solutions. If it is no solution, then that means that the lines have the same slope but different y-intercepts. Okay? If it is infinitely many, did I spell that right? Then that means they have the same slope and same y-intercept. Kind of like when we did the graphing. The one that was the same line, that line, those two lines had the same slope and same y-intercept. The one that the two parallel lines, they were same slope but different y-intercepts. So that's basically what we're looking at on these. I don't think any of these are going to say one solution. So what I want you to do is take both equations and solve them each for y. So equation number 1. Now, because we're not graphing, it is okay for these to be decimal answers. Oh, goodness. And actually, some of these are even going to be a combination because I'm not going to get all nitty gritty into the fraction and decimal stuff because we're not graphing. We're just trying to compare. So I'm going to divide by 15 over here for every term. Now, negative 22.5 divided by 15 is negative 1.5x, plus 40 over 15 reduces to 8/3. So the slope is negative 1.5. The y-intercept is 8/3. Over here, I need to subtract 4.5x. And I get 3y equals negative 4.5x plus 8 over 3. And so that's y equals, making sure I wrote this down right. Yep. Y equals negative 4.5, negative 1.5 x plus 8 over 3. So the slope is negative 1.5 and the y-intercept is 8/3. So they have the same slope and the same y-intercept. This is infinitely many solutions. So all we're doing is solving for y and comparing their slopes and their y-intercepts. Okay, number 2. Top equation is 10y equals negative 15x plus 60. The second equation, 3x plus 2y equals 12. All right, so we're going to, on this first equation, divide each term by 10. And we get y equals negative 1.5x plus 6. So the slope is negative 1.5. The y-intercept is 6. Over here, we're going to subtract 3x. And we get 2y equals negative 3x plus 12. That's a 12. It's a messy 12, but that's a 12. So y equals negative 1.5x plus 6. So again, the slopes are the same and the y-intercepts are the same. So if they're both the same, it's infinitely many solutions. All right, number 8. The first equation, that's 14. We're going to solve for y. So subtract 8x, and I get negative 8x plus 14 equals 5y. So that's negative 8/5 x plus 14 over 5 equals y. So here the slope is negative 8 over 5. The y-intercept is 14 over 5. All right, equation number 2. 8x plus 5y equals 13. Subtract 8x. And I get 5y equals negative 8x plus 13. Divide by 5. So y equals negative 8/5 x plus 13 over 5. So here the slope is negative 8/5 and the y-intercept is 13/5. Now, same slopes, different y-intercept means no solution. And the y-intercepts are different because one is 14 over 5, the other one's 13 over 5. So this is no solution. Right, one more. So top equation, equation number 1, solve it for y. And we get negative 4x plus 20 equals 3y. Divide by 3. So negative 4/3 x plus 20 over 3 equals y. So here the slope is negative 4/3 and the y-intercept is 20 over 3. Second equation, 4x, man, my 2's are messy. 4x plus 3y equals 11. Subtract 4x and divide by 3. So y equals negative 4/3 x plus 11 over 3. So here the slope is negative 4/3, same as the first equation, but the y-intercept is different. It's 11 over 3. So this is no solution. Okay, so that's all you have to do on those. In order to tell whether it has one solution, which these will not have one solution, infinitely many solutions or no solution, then you have to solve them for y and compare. Same slope, same y-intercept, that's infinitely many solutions. Same slope, different y-intercept, that's no solution.